Jai Shri Gurudev. Good morning to everyone student. Welcome to chemistry class. In previous classes, we learned about the nomenclature of haloalkanes and haloarenes. Then the methods of preparation of haloalkanes and the properties means both physical and chemical properties of haloalkanes. That is called haloalkanes or alkyl halides. In this session, we are going to study about the methods of preparations of haloarenes we called aryl halides. That is preparation of aryl halides. There are so many methods to prepare aryl halide. Some are we are studying here. The first method is by electrophilic substitution reaction. By electrophilic substitution reaction. In this method, the aromatic hydrocarbons like benzene, toluene, aniline, etc. anyone you can take. The aromatic hydrocarbons is treated with halogens such as chlorine or bromine in presence of ferric chloride or anhydrous aluminum chloride or ferric bromide reagent. You get respective halogenated hydrocarbon. That is, example, take benzene. You know this is a benzene. Either you write like or you can also write like that. Anyone. This benzene is treated with halogens such as chlorine or bromine. Better take chlorine or take bromine your wish. In presence of ferric chloride FeCl3 or in presence of anhydrous aluminum chloride AlCl3, ferric chloride or aluminum chloride. Either write anyone, you get respective halogenated compound. So observe here there is one hydrogen. Means all the 6 carbons or each carbon on benzene having one hydrogen, right, like that. Hence the molecular formula of benzene is C6H6. So here there is a one hydrogen. This one hydrogen and one chlorine of this chlorine molecule becomes HCl. And in place of hydrogen, the chlorine is substituted. That process we called substitution reaction. Here chlorine is an electrophile, hence we called electrophilic substitution reaction. Okay. So what you get here? Benzene. In place of hydrogen, chlorine is substituted. That is, we get chlorobenzene. This chlorobenzene is obtained from benzene. So this is one of the method to prepare aryl halide, that is halogenated benzene compounds or aromatic compounds. Similarly, now take one more example. In place of benzene, take toluene or take benzene only. Benzene, which is treated with bromine. Br2 in presence of ferric chloride FeCl3 or in presence of anhydrous aluminum chloride AlCl3. Write anyone, no need to write both. You get here observe there is one hydrogen, right? Hydrogen Br becomes HBr and you get the respective halogen compounds. Here you get bromobenzene Br plus HCl. So not Cl, HBr. So what its name? Bromobenzene. Similarly, if you take toluene, so this is a benzene. You know the molecular formula of toluene or structure of toluene is CH3. Benzene that having one CH3 group. Its molecular formula is C7H9. 9. 1, 2, 3, 4, 5 hydrogens. 5 plus 3, 8 hydrogens. C9H8. This is the molecular formula of benzene toluene. Now observe, this toluene is reacts with the chlorine in pairs of ferric chloride and ferric chloride and anhydrous aluminum chloride. You get respective halogenated compound of toluene. In this case, you get two products. One is ortho product of toluene and one more is para product of toluene. Okay, because this toluene is an electron donating group, because presence of CH3 group, it shows positive inductive effect towards the benzene ring side. Hence, the substitution is occur at two sides. One is ortho portion and one more is para portion, and this is the meta portion. Okay, in the nomenclature I explained, when benzene is substituted by any one of the group, here any one of the group is substituted, generally I write G. According to this group or respective to this group, the neighboring sides, these two we call ortho groups, and the exact opposite this group is para group, and remaining these two are what? Meta groups. So that is simply indicates meta M, ortho O, and the para portion is P, like that. You should remember these positions. So here this G group is what? CH3. That is an electron donating group. Hence you get two components or two products. One is the ortho substituted product and one more is para substituted product. Those two are here. So observe, ortho means this one. This is the ortho position. Here there is one hydrogen. This hydrogen and Cl becomes HCl. You get in place of here hydrogen, you get Cl. One product. Here there is a para portion. This is also having one hydrogen, right? This hydrogen and Cl becomes HCl, and Cl will be substituted here. You get what? And one more product, that is this one. Here CH3. Here hydrogen is replaced by writing chlorine. So elimination of two equivalents of hydrogen halide. To balance this chemical equation, you take two equivalents of toluene and two equivalents of chlorine. The reagent will be required amount we are putting while doing the chemical reaction. So this is mainly, its name is what? Toluene. So the product name is, this is ortho portion. So that orthochlorotoluene, this is the second portion, 1, 2, that is 2-chlorotoluene, and this is 1, 2, 3, 4, that is 4-chlorotoluene. Its name is 4-chlorotoluene. This is the products we get when we are taking toluene as an reagent or aromatic hydrocarbon is an reactant. So similarly, if we are taking here CH3 toluene and we are doing bromination Br2, so what kind of products you are expected? Right here. So what kind you are expected? Right? This is common for you. So the next method is, the second method is Sandmeyer reaction. Sandmeyer reaction or from diazonium salts. From diazonium salts or Sandmeyer reaction important. In Sandmeyer reaction, the benzene diazonium salts is treated with the cuprous chloride in presence of hydrogen chloride or cuprous bromide in hydrogen chloride. You get respective halogenated compound that is called halide. So that is benzene diazonium salts. This is benzene diazonium. Diazonium, the word itself says diazonium. So here observe, di means two, azo means nitrogen. Azo means nitrogen. So put two nitrogens here. One double bond N. This is the diazonium. Salts means right halogen. So this is called benzene diazonium halide. Benzene diazonium halide. This benzene diazonium halide is treated with cuprous chloride CuCl2 in hydrogen halide, that is HCl. You get respective halogenated compound, that is benzene. So listen here, nitrogen and nitrogen becomes nitrogen gas, that is N2 gas, eliminated plus. Here there is chlorine, right? This chlorine is substituted this here. One hydrogen, this one, and this X becomes HX. So in Sandmeyer reaction, you get an aryl halide that related to the HCl or the cuprous chloride in taking which hydrogen halide solvent. Either you take hydrogen chloride, you get chlorobenzene. If you take hydrogen bromide, you get bromobenzene. It means the final resultant product is depends only the type of reagent we are taking along with the cuprous chloride. Okay, so here we get chlorobenzene. Chlorobenzene. So if you take this benzene diazonium halide is represented BDH simply. So similarly, this benzene diazonium halide N double bond N bond X, which is treated with cuprous chloride in presence of hydrogen bromide HBr. So what type of product is expected here? Due to presence of HBr, you get bromobenzene. Right now. So this is benzene. Here bromine plus nitrogen and nitrogen means N and N becomes N2 nitrogen gas. Eliminated. This oxide aroma indicates elimination, means liberation. So this X and H becomes HX, and in place of nitrogen Br is substituted. So this is also a kind of electrophilic substitution reaction, but this Sandmeyer reaction takes place by free radical mechanism. Okay, so this is the preparation of aryl halides from benzene diazonium salts. This reaction we called Sandmeyer reaction. Now take the third method. Next concept, note in diazotization reaction. In diazotization means in Sandmeyer reaction we are taking note important, that is diazotization. This is the diazotization. So important. This diazotization is a process of preparation of diazonium salts, that is benzene diazonium salts. To prepare benzene diazonium salts, aniline, this is an aniline, NH2. This aniline is treated with sodium nitrate NaNO2 in hydrogen halide. So I can write like that. This is treated with sodium nitrate NaNO2 in hydrogen halides at 0 to 5 degrees Celsius. This is the required temperature. In this condition, this aniline is converted into diazonium salt. You know benzene diazonium salt? Benzene diazonium is two nitrogens. Bond here there is X, right? That X. So this is called benzene diazonium halide. diazonium halide. So this whole process or reaction we called as a diazotization. So keltare 2 marks be important to what is mean by diazotization, explain with reaction and the keltare. Then you write in diazotization process, haloarene is treated with sodium nitrate in hydrogen halide at 0 to 5 degrees Celsius. You get the benzene diazonium halide. This reaction is called as diazotization and write the chemical reaction. Okay. Now from this reaction to prepare respective hydrogen halide, we are treating in the previous reaction, means in the last reaction. This benzene diazonium salts is treated with cuprous chloride in presence of hydrogen chloride to prepare what? Chlorobenzene, right? But to prepare a hydrobenzene, it should no need to treat with cuprous chloride because the hydrobenzene is prepared easily from diazonium halides by treating with only the hydrogen iodide or potassium iodide salts. So to prepare aryl iodide means hydrobenzene. So listen, to prepare hydrobenzene, this benzene diazonium salt N double bond N bond X, which is treated with the potassium iodide. It is enough. No need to treat with cuprous chloride because this hydrobenzene potassium iodide is more reactive with this BDH, benzene diazonium halide. With this one more reactive, hence you get hydrobenzene plus high substituted here, nitrogen and nitrogen becomes nitrogen gas plus this K and X becomes K. This is the one of the method to prepare hydrobenzene. So remember, to prepare hydrobenzene, no need to add cuprous chloride. However, to prepare chlorobenzene or bromobenzene, you should treat it with cuprous chloride with hydrogen halide to get respective aryl halide. That process is called Sandmeyer reaction. This process is called as what? Diazotization. So this is the diazotization reaction. This one. This much is it. The next concept is properties of haloarenes, or we also called aryl halides. That is properties of aryl halides. So you know there are two types of properties, physical properties and chemical properties. Let's take the first one is physical properties. In physical properties, the boiling point of aryl halides is increases with increasing the size of an halogen atom. Size of an halogen atom, that is example aryl halide, that is this is hydrobenzene. It has a high boiling point. Then the bromobenzene, then the chlorobenzene, then the fluorobenzene. So this is the increasing order of boiling point. This is the order of boiling point. So listen, what we are saying, the size of an halogen atom increases, the boiling point increases due to high mass. That is, hydrobenzene is high boiling point, then bromobenzene, then chlorobenzene, and fluorobenzene is the least one. If the isomeric dihalogen halides, the boiling point is almost similar. However, the chlorobenzene means dichlorobenzene, orthodichlorobenzene, is higher than the meta-dichlorobenzene, then the para-dichlorobenzene, but almost similar. That is the second physical property in isomeric dihalides. Isomeric dihalides means The molecular formula is the same, but the structure is different. That is called isomeric dihalides. For example, take this is the chlorobenzene. If chlorine is substituted at Hartog position, it is called orthodiachlorobenzene. This one has a high boiling point. This is boiling point in isomeric dihalides. This is high boiling point. Then it is helpful for your CET, NEET, JEE and IIT exams. Listen. This is chlorobenzene and this is the metachlorobenzene. So this one is a bit higher than the orthodiachlorobenzene. Sorry, paradichlorobenzene. So this is the increasing order of boiling points in isomeric dihalides. Okay, due to the close packing in crystalline lattice. Crystalline lattice and the close packing ಮೇಲೆ depend ಆಗಿರುತ್ತೆ. Hence this is the increasing order of boiling point. Then the melting point is exactly opposite of this one. That is the third case. The melting point in isomeric dihalides is this orthodiachlorobenzene is least one. It means paradichlorobenzene is higher melting point than this metadichlorobenzene. Then orthodiachlorobenzene. This is the orthodiachlorobenzene. This is the boiling point order of this isomeric dihalides. Then similarly, the density and dipole moment is same like this one. So the boiling point order means order of boiling point or density or dipole moment will be same for all these compounds in this order. ಈ ಆರ್ಡರ್ ಅಲ್ಲೇ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಆಗಿರಬಹುದು, ಡೆನ್ಸಿಟಿ ಆಗಿರಬಹುದು, ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಆಗಿರಬಹುದು ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ ಈ ರೆಸ್ಪೆಕ್ಟಿವ್ ಹ್ಯಾಲೈಡ್ಸ್. ಓಕೆ, ದಿಸ್ ಇಸ್ ದಿ ಫಿಸಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಅರೈಡ್ ಹ್ಯಾಲೈಡ್ಸ್. ನೌ ವಿ ಆರ್ ಮೂವಿಂಗ್ ಟು ಸ್ಟಡಿ ಕೆಮಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್. The next property is chemical property. So in chemical properties, the aryl halide, very important. Remember, aryl halide halides are less reactive towards nucleophilic substitution reaction. Towards nucleophilic substitution reaction, then alkyl halides. Because so here what we are saying, the aryl halides are less reactive towards nucleophilic substitution reaction than alkyl halides called haloarenes. Because the one is resonance effect and the second one is hydration of carbon. Or halogenated carbon. Then the third one is bond strength or instability of phenyl carbocation. These are the three main reasons to decrease the reactivity of aryl halide towards the nucleophilic substitution reaction. Now let me study this one by one. What is mean by resonance effect and hydration of halogenated carbon, and why the phenyl carbocation is unstable means less stable. So now take first one, resonance effect. So this is very important. Definitely they will ask for 2 months. suggest aryl halides or less reactive towards the nucleophilic substitution reaction than alkyl halides anta. So you can write these three reasons. Now resonance effect. So observe in resonance effect, you take the halogen. This is halogenated compound. Generally I am taking X. This X is either fluorine, chlorine, bromine or iodine. This is halogenated compound called haloarenes. Here the halogen containing 3 pairs of lone pair electrons, right? In halogen there is 7 electrons in their outermost shell. 1 electron is shared with the benzene to make a bond with the benzene. And there is 3 lone pair of electrons, means 6 electrons. Due to the richness of electrons, it undergo resonance with the benzene electrons. Benzene alliruವಂತ electrons ಜೊತೆ ಏನಾಗುತ್ತದೆ resonance ಗೆ involve ಆಗುತ್ತೆ. So during that time these 2 electrons moves here and these electrons move on benzene. ಅಂದ್ರೆ ಏನಾಯ್ತು ಇಲ್ಲಿರುವಂತ lone pair electrons move ಆಯ್ತು, ಇಲ್ಲಿರುವಂತ ಬಾಂಡ್ ಈ ಕಾರ್ಬನ್ ಗೆ move ಆಯ್ತು. So what you get a structure like that. So X that having 2 pairs, here one bond is newly formed, right? So by losing of electrons from halogen, it carries positive charge, and the electrons here is there. These electrons, it moves on benzene. Hence benzene carries negative charge, and remaining 2 bonds we are not disturbing, right? Those 2 write as it is same. You get this resonance structure. Now again this negative charge is unstable as it moves towards here. This towards the double bonded or electron side, it moves the neighboring carbon, moves on neighboring carbon. So what you get, the one more structure X lone pair electrons, it carries positive charge. So write as it is same, whatever we are not disturbing that one. So this bond is only we are disturbing, write that one here minus and like. So again we get one more structure. This is moves towards double bond side, it move on neighboring carbon. So it should show the arrow marks. Otherwise you lose marks. So write same as it is, bond here bond and minus charge. So these are the resonance structures. Again it moves towards the double bonded side and it neutralizes the positive charge. So you get the beginning structure, bond, bond, bond and X. So observe what is the difference between this first structure and this last structure is the double bond position is different. So here the 2 double bonds are present left side and one is right side, but here observe these 2 are right side, this left side. Between these 2 there are these 3 structures we called resonance structures. Resonance structures. Okay, this is the one reason. This indicates the strong strength of the halogen and carbon bond. ಇಲ್ಲೇನಾಗ್ತಿದೆ ನೋಡಿ, one bond ಇರೋದು double bond nature ತೋರಿಸ್ತಿದೆ. These 5 electrons are not stable, they are resonating along with the halogen. Hence the halogen and carbon bond strength is high. It is not easy to broken. So that this aromatic halogenated compounds are we called aryl halides or less reactive towards the nucleophilic substitution reaction. Okay, this is one reason. Then the second one, what we are saying, hybridization of carbon atom, right? Hybridization of halogenated carbon atom. Hybridization of halogenated carbon atom means carbon and halogen hybridization. So see here in halogenated carbon, this is halogenated carbon, we are taking benzene. What is the hybridization of this carbon? How many bonds are there around it? 1, 2, 3, 4 bonds is there. Out of 4, 1, 2, 3, 3 is sigma bonds, 1 is pi bond. So when there is 3 sigma bonds and 1 pi bond, the hybridization is sp2, right? In sp2 hybridization, the s character is high. sp2 ಅಂದ್ರೆ 2 p ಇದೆ, 1 s ಇದೆ. ಎಷ್ಟರಲ್ಲಿ 100ರಲ್ಲಿ 2 p's 2 p's 1 s ಇದೆ. ಸೊ ಶೇರ್ ಮಾಡಿದಾಗ ಎಷ್ಟು ಕ್ಯಾರೆಕ್ಟರ್ ಬರುತ್ತೆ? 33. 0.33 S character ಬರುತ್ತೆ. The double P character 66.66 ಬರ್ತಾ ಇರುತ್ತೆ P character. Okay, sp2 hydrogen. You know in first year how to find the S character and P character. So similarly take alkyl halide. In alkyl halide CH3 bond X. This is alkyl halide. How many bonds are there around here? Carbon, there is 3 hydrogens, means there is 3 hydrogens like that, 3 bonds. 1, 2, 3, 4 sigma bonds. There is no pi bonds. Hence its hydration is sp3. It means there is 1 s and 3 p. 1 s and 3 p's. So 100 ಅಲ್ಲಿ divide ಮಾಡಿ, each one get 25. Here 25 and here 75%. So that the percentage of S character increases, the bond strength also increases. That is the one reason. To less reactive towards the nucleophilic substitution reaction of aryl halide. Then what is the third reason? The third reason is instability of phenyl carbocation. Instability of phenyl carbocation is the third reason. So now take phenyl carbocation. You get take the benzene ring or aryl halide. This is aryl halide. And you know, in the beginning only I told you, among carbon and halogen is more electronegative than carbon. Therefore, this bonded electrons moves towards halogen side. During that time, you get phenyl carbocation. Phenyl carbocation, called benzene carbocation and X minus. Now, this phenyl carbocation is instability, means unstable due to no resonance. Benzene ಮೇಲೆ electrons deficient ಆಗಿರೋದ್ರಿಂದ ಏನಾಯ್ತು, ಬೆಂಜಿನ್ ಅನ್ನೋದು ಹಕ್ಕಲ್ಸ್ ರೂಲನ್ನ ಒಬೆ ಮಾಡೋದಿಲ್ಲ ಮತ್ತೆ ಅನ್ಸ್ಟೇಬಲ್ ಆಗೋದ್ರಿಂದ ಲೆಸ್ ರಿಯಾಕ್ಟಿವ್ ಆಗುತ್ತೆ. ಅದಲ್ಲ, ಯೂಶುವಲಿ ಸ್ಟೇಬಲ್ ಆಗಿದ್ರೆ ಲೆಸ್ ರಿಯಾಕ್ಟಿವ್. ಇಲ್ಲಿ ಬೆಂಜಿನ್ ಕಾರ್ಬೋಕೇಟೈನ್ ಏನಾಗ್ತದೆ, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬಂದಿರೋದ್ರಿಂದ ನ್ಯೂಕ್ಲಿಯೋಫಿಲಿಕ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ರಿಯಾಕ್ಷನ್ಸ್ ಲೆಸ್ ಇನ್ವಾಲ್ವ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಮಾತ್ರ ಬೆಂಜಿನ್ ಅಲ್ಲಿ ಮಾತ್ರ, ಯಾಕೆಂದ್ರೆ ಇಂಡರೆನ್ಸ್ ಕ್ರಿಯೇಟ್ ಆಗಿದೆ, ಇಂಡರೆನ್ಸ್. ಬಟ್ ಇನ್ ಆಲ್ಕೈಲ್ ಹ್ಯಾಲೈಡ್ಸ್ the carbon carries positive charge. It means it is more reactive towards the nucleophilic substitution reaction. Okay, this is the properties, chemical properties of aryl halide. Now we are going to some chemical methods, means some chemical reactions of aryl halides. Okay.